So, welcome to another lecture. In this lecture, we'll be doing rates of reaction. This is a IGCSE topic. So, fairly interesting topic and fairly easy topic. But what I've realized is that the students don't use the appropriate words. There are exact words that you need to use when you are answering the questions. It will be a pretty exhaustive lecture where we'll be going through all the concepts which are there in the topic using the board papers only. But my request to you would be, please look at the exact words that are being used when you are answering the question. Activation energy is one of the hot topics from this chapter. A lot of questions are asked from activation energy. But when you are explaining activation energy or when you are explaining questions based on activation energy, my request to you would be to use the appropriate words, to use the words as are mentioned in your textbook. Please don't answer the question as if you are answering to your friend on WhatsApp. Please don't do that. So let's start. The graph shows the result of adding excess calcium carbonate to hydrochloric acid at 50 degrees Celsius and at 30 degrees Celsius. Only the temperature is changed. Only the temperature is being changed. Which row describes the reacting particle at 30 degrees compared to those at 50 degrees? Now you guys understand that what does the temperature do? Temperature increases the rate of reaction. Rate of reaction, what that implies is you understand that rate of reaction is given by slope of the curve. So here, if I draw a slope, say at this point, the slope would look something like this. But here, the slope would be something like this. The slope is more here, the slope is less here. So the rate of reaction at 50 degrees Celsius is more. That is the first thing that I want to discuss. The second thing that I want to discuss is, finally, if you see the total volume of CO2 given off in centimeter cube remains the same. That is another thing that I want to discuss. The total volume at the end of the reaction remains the same. But in 50 degrees Celsius, what happens is that the point is reached first. The completion of the reaction is reached first. So if you see somewhere here, the time of reaction, approximately here, the time of reaction is complete. But here, if you see in the lower graph, if you see the time of completion is about this. So another way of looking at this is that when you increase the temperature, the time in which the reaction gets completed, when you increase the temperature, the time to reach the conclusion is faster. So here, the time to conclude the experiment is faster. Here it will take, at 30 degrees Celsius, it will take more time. So that is the second thing that I want to explain. And because my intention is that when we are discussing the questions, questions will be understanding the concepts also behind it throughout this lecture. Now, regarding temperature, when I'm discussing temperature in rates of reaction, I request you to have a look at this chart also again and again. I'll be sharing this chart in the comments below. So please keep referring to the effect that, say, a temperature or concentration or surface area or catalyst have on the rates of reaction. Now, temperature, what does the temperature do? It basically increases the average kinetic energy of the particles. So the average energy increases, and due to the increase in temperature, because the energy has increased, the collision frequency will increase. It is just like saying, one example that I can take is that try to play football when you are hungry. You are low on energy. You are not feeling so good. But let us assume that you had good meal, not very hearty meal, but decent amount. At least you are energetic. Now, when you are energetic, when you have energy in you, and then you are playing football, the collision frequency that you will have with the other players would be more. I hope this is a rough example. Hope it is making sense. So what I'm trying to explain is, what does the temperature do? What does increase in temperature do? Basically, the increase in temperature increases the collision frequency. The first is the collision frequency, and the second thing that happens is the energy of collisions also increases. Again, if we take the football example, you are low energy, One is the collisions, number of collisions would be less, and the second would be the frequency, the energy would also be less. But you know, you are feeling energetic. The more running around you will be doing, and when there will be collisions, there will be the more energetic collisions would be there. Hope this is making sense. So this is what increase in temperature does. So to answer the question, the frequency is also higher. Frequency of collisions between particles is also higher, and the average kinetic energy of particles is also higher. When they collide, when two particles collide, the frequency is also more of collisions. The frequency is also more, and the energy at which they collide is also more. Hope this is making sense. Because as I have told you earlier, that we will be using we need to use exact words when we are answering the questions. Though this is MCQ, but in theory questions, you'll have to use the exact words. It's the effect of adding a catalyst to a chemical reaction. Okay, so like we are doing in all the questions, I'll be going in bit of detail when I'm explaining this question. See, what is the role of activation? So, what is the role of a catalyst? This is beautifully explained by this diagram. So this is the reaction path. This is the energy. So this is what a catalyzed path does. So this is the rule. This is the role of a catalyst. So what a catalyst does is basically, if there was no catalyst, then the reaction would have taken this part, where the energy of activation would have been more. Same is being explained here also. If you see, the activation energy is more when you are doing a reaction without catalyst. But when you are doing the reaction with catalyst, the activation energy is lesser. When you are doing reaction with catalyst, the activation energy is lesser. The activation energy is lesser because a catalyst provides a easier path for the reaction. So that is what the role of catalyst is. Hope this is making sense. I've also captured this here. So what does a catalyst do? A catalyst increases reaction rate without being used up. That is the first property. Provides an alternate pathway with lower activation energy. It provides an alternate with a lower activation energy. For example, when you will be doing Haber process, there will be catalyst which will be used. So that is the role of a catalyst. The option that we have is activation energy EA of the reaction is increased. So this is wrong. Wrong because the activation energy, as we have seen, activation energy of the reaction decreases. But here it is mentioned that the activation energy increases. So that's why this one is wrong. The frequency of collision between the particles is decreased. Again, you have to be very clear. The catalyst has nothing to do with the frequency of collisions. They are not related. So this is wrong. The kinetic energy of the particles is increased. Again, this is not something which is related to the catalyst. If you have looked at the earlier question, the frequency of the collision and the kinetic energy of the particles is related to the temperature, which we did in this question. It is not related to the catalyst. So here I have briefed you about the action of a catalyst. A catalyst increases the rate of reaction by reducing the amount of energy that is needed to break the bonds. This reduces the activation energy of the reaction and makes sure that more collisions are likely to produce products. Because the activation energy has decreased, so more collisions are likely to produce the product. Very important property of catalyst, it remains chemically unchanged, and because it is unchanged, the catalyst can be used again. So that is why it is cost effective also. I'll just briefly go through the enthalpy of a reaction. This enthalpy of the reaction stays unchanged. This is the answer to this question. If you know about enthalpy, great. If you don't know, because it is covered in another chapter, but I'm just briefly going through the concept here. So enthalpy change is the heat energy transferred at constant pressure, indicating if it is exothermic. So it can be exothermic if delta H is negative. That is something that you need to remember. If delta H is negative, heat is released. It's an exothermic reaction. The temperature rises. If it is an endothermic reaction, the reaction absorbs heat. Delta H is positive, and the temperature drops. This is something which I just wanted to discuss because enthalpy is mentioned here. We'll do this in detail when we are doing the appropriate chapter. Let's go to the next question. Let's move to the next question. the rate of reaction between magnesium dilute HCl is increased by increasing the concentration of the acid. How does this affect the reacting particles? So right now they are discussing about increasing the concentration. Now, as I have explained before, previously we have discussed the effect of temperature change on rate of reaction. We have understood the effect of catalyst on chemical reaction. Here they are asking you about the increase in concentration. And what I had explained before was you should be very clear how each of these affect the rate of reaction. So, for example, concentration. What does concentration do? Concentration will increase the number of reactant particles per unit volume. This is the contribution of concentration. So what does concentration do? Is like an example that I can take is you go to the railway station during the rush hour, say in the morning hours or in the evening hours. So the number of reactant particles per unit volume has increased. But what you need to understand is that this is the only factor that changes. So for example, in this question, the number of particles per unit volume has increased. Therefore, the collision rate of the particle has increased. But the proportion of particles with sufficient energy to react stays the same. There is no change in the energy of the particles. The only thing which the increase in concentration has done is because in our example, the number of people in the railway station is more. So the collision rate will increase, but the energy of the passengers at the railway station is the same. Concentration won't increase the energy. So, for example, temperature would be responsible for increasing the energy. Concentration is not one of the factors which increases the energy of the particles. I mentioned this here also. Minimum energy required for a successful reaction is a property of the reaction itself, does not depend upon the changing concentration, does not alter the temperature or energy distribution of the particles. So, you have to be clear about what factors affect which part of the reaction. To be very clear. So let's move to the next question. So there is some reaction which is taking place. We can ignore that. Is repeated using sulfuric acid of concentration 0.2 mole per decimeter cube instead of 0.1 mole per decimeter cube. So in this question, this is a reaction which was taking place. You can go through this. The point that I want to emphasize here is the concentration is increased to 0.2 mole per decimeter cube instead of 0.1 mole per decimeter cube. So rest of the conditions, as I mentioned here, all the other conditions remain the same. The rate of reaction has increased. So why the rate of reaction has increased? The rate of reaction has increased because you have increased the number of particles in the given volume. So in 1 decimeter cube, previously there was 0.1 mole of particles, but now in 1 decimeter cube, there is 0.2 mole. You have doubled the number of particles. So that is why the number of collisions, the chances of the collisions will increase, and that is why the rate of reaction will increase. So the speed of reaction is faster. I have mentioned it here. More concentration means that there are more reactant particles in a given volume. The more they collide, the more chances of particles have to react. This means the rate of chemical reaction will increase if the concentration of the reactants is increased. As I've told you before, you have to be very clear about the language that you are using. So, for example, in this question, you need to mention that there are more reactant particles in a given volume. So, this phrase has to be mentioned when you are answering the question. The theory question, MCQ is fine, but when you are answering this question, so for example, this is a 2-mark question, you have to be clear about your wording. The appropriate word should be. Next question again is a very interesting question. For a simple reason, because a lot of factors are being discussed in this question, and I'll take some time to explain this question. Actually, more time than is necessary because this is MCQ. But let's start. Sulfur dioxide is converted to sulfur trioxide in a contact process. This is contact process is again one of the topics in your syllabus. The condition used are this is the temperature, this is the pressure, and this is the catalyst which is used. This particular reaction, which row describes and explains the effect of changing condition on the rate of reaction. So this would be in this row, in this column, you'll have the change of condition, and in this column, there will be explanation. And as I've told you before, we'll be going through this in detail. So they have the factors that they have all the factors that we require, they have discussed here. They have discussed catalyst, they have discussed pressure, they have discussed temperature, they haven't discussed concentration. So the first thing that I'll do is I'll quickly take you through the effect of catalyst, pressure, and temperature on the rate of reaction, and then we'll look at this. So this is a document that I have made, and these are the conditions which are given in the contact process. Now, what you need to understand is what is the effect of catalyst. What does a catalyst do? A catalyst just lowers the activation energy by providing an alternative reaction pathway. So, this is a diagram that I find which captures the essence very, very beautifully. So, the effect of catalysis is that there is an alternate path which requires lower energy. So, this is what is the role of catalyst. Always, whenever you see a question related to catalyst, always keep in mind this diagram. So, by removing, when you remove a catalyst, you basically increase the activation energy, and of course, it will slow down the reaction. So, this is the role of catalyst. What is the role of pressure? See, by increasing the pressure, you are increasing the number of particles per unit volume. So, quickly, I can show you the essence of this. So, let us assume that we have some arrangement like this. The reaction is taking place here. Now, if I increase the pressure, let us say I push the piston down, I push it, this is a new condition. So you'll see that the number of particles per unit volume has increased because the volume has decreased. So number of particles per unit volume has increased. So I hope you get the sense. So what does the pressure, increasing pressure do? It increases the number of particles per unit volume. And of course, when the more number of particles are squeezed in a smaller volume, the collision frequency increases. But the thing to remember is that the pressure does not increase the kinetic energy. This is something which you need to understand. The kinetic energy, always remember, the kinetic energy just depends upon the temperature. This is a very important thing that you will also study in higher grades. The temperature just affects the kinetic energy of the molecules. The kinetic energy of the molecules is just affected by the temperature. Remember that. So what does the effect of temperature do? Increases the average kinetic energy, increases collision frequency. Of course, it will increase the collision frequency, increases the fraction of particles with energy greater than activation energy. So this is another thing that you need to understand when you are discussing the effect of temperature. Now let us look at each of the rows. So first is there is no catalyst. You are not using catalyst. Of course, this will lower the rate, and the answer would be because the activation energy is higher. You have there is no alternate path which is available. This is what we saw here. So if you remove this path, if you remove the catalyst, this path is removed. So the reaction will have to take the path which uses more activation energy. And always remember that the symbol for activation energy is EA. This is how it is written. So this is the correct answer. So the correct answer is A. But let us look at the other options also. So higher pressure. Now you have increased the pressure. Yes, the effect on the rate of reaction would be the rate of reaction will increase. But the explanation which is given is wrong. The particles will have more kinetic energy. Oh, that is wrong, as we have discussed before. Next, lower temperature. Okay, the effect of on rate, of course, the reaction will rate of reaction will lower. But again, the particles will collide more frequently. That won't happen. Lower pressure, effect on rate, no, it won't be higher. It will be lower. There are more particles per unit volume. Here, the changing condition is the effect on rate is also wrong, and the explanation is also wrong. So this is a note I have prepared. I'll be attaching this note also in the comment section. You can have a look at the note, because that is what I was trying to tell you, that in this question, a lot of things get cleared. And as I've told you before, same question can be asked in theory, but when it is used in theory, when this question in some form comes in theory, you have to be very clear about the language you are using. You should be very precise in answering the question. Don't answer like I've said before. Don't answer like you are answering to your friend on WhatsApp or Instagram. So in this question, we'll be discussing the graph-based questions, which are usually asked in the rates of reaction chapter. So we'll be doing two questions. Let's start with the first question. Student investigate the reaction of magnesium with dilute S2SO4 sulfuric acid. So complete the word equation for the reaction magnesium with dilute sulfuric acid. So Mg plus H2SO4 dilute will give magnesium sulfate plus hydrogen. Hydrogen gas would be given out. The student sets the experiment to investigate the rate of this chemical reaction. Carries out the reaction at 25 degrees using 2 gram of magnesium ribbon and 25 centimeter cube of dilute H2SO4. So this is the setup. Measures the total volume of gas produced at regular time intervals. Plots a graph of the result. So he takes dilute H2SO4. He puts 2 gram of magnesium into it. This is a setup. This temperature is taking place at 25 degrees Celsius. Then he plots a graph also. So the graph looks something like this. This one. So the graph is between time. The axis that he has taken is time axis as x-axis, and this is the total volume of hydrogen gas which is produced in centimeter cube. So this is the hydrogen gas which is produced. Now this temperature that he has done, this is at the temperature at which he has done the experiment. Now the first question which is being asked is, reduce the total volume of hydrogen gas produced in the first 100 seconds of the reaction. It's a graph based question. So if you look at the 100-second point and you see the point here, this is 30 centimeter cube. So this point is 30 centimeter cube. Simple question, you just have to read the graph, and that is what I have written at 30 centimeter cube. So just why the reaction stops at 300 degree, 300 second. So the magnesium which is there, quantity of H2SO4 is more. So the magnesium which is there, the 2 gram of magnesium rich ribbon which was used, so it is completely used up. So the reaction stops. The experiment is repeated at higher temperature. Now, as we have been discussing before, at higher temperature, the rate of reaction would be more. But one thing that you need to remember is the rate of reaction would be more. But the quantity of, the volume of the hydrogen gas which is produced would remain the same. So, what I'm trying to tell you here is that at 25 degrees Celsius, this was the total volume of hydrogen gas which was produced. So, this is the 80 centimeter cube mark. When you increase the temperature, at higher temperature, draw a line to show the volume of gas produced changes at higher temperature. The volume of gas which is produced, hydrogen gas which is produced, would remain the same. But the big difference that will come is that the rate of reaction will increase. And the rate of reaction is given by the slope of the line. The slope of line, this line is more than the slope of this line. So hope this is clear. I want to show you another question which is not a graph based question, but will specify this point, will emphasize this point. Let's have a look at that question also, and then we'll come back to another graph based question. So if you look at this question, sample of calcium carbonate with dilute HCl to produce final volume of 60 centimeter cube of gas. The reaction takes place in 120 seconds. So this reaction, the first part, gets over in 120 seconds. The experiment is repeated at lower temperature. Now, if you see at lower temperature, see the volume of gas which is produced would remain 60 centimeter cube. That won't change. But because the experiment is being done at lower temperature, the time will increase. From 120 seconds, now it is taking 160 seconds. The volume of the gas would remain the same. That is the point that I want to emphasize. Now let's move to the another graph-based question that I want to show you, because graph-based questions are also important. Rest of the questions we'll be doing in the separate lectures. So this is the question I want to show you. Shows a graph of the mass against time. So this is the mass and this is the time. So there is a reaction which is taking place. I haven't copied the experiment, so it doesn't matter. So the experiment is repeated at higher temperature. All other conditions remain the same. The collision theory temperature I have discussed separately, so I don't want to go into this. This is the question I want to discuss here. This part of the question I want to discuss here. Sketch the line expected when the experiment is repeated at higher temperature. So see, this is a temperature T1, and now what you need to see is that this is the final mass. At higher temperature T2, T1 is less than T2. So this is the temperature T2. What you need to understand is that the rate of reaction will increase, but the final mass would remain the same. So that is why I have shown the line something like this. This is the slope that we will be following now. I'm trying to smoothen the curve. The rate of reaction will increase at higher temperature, but the T here is temperature, not time. The rate of reaction increases at higher temperature. At higher temperature, rate of reaction increases, but the final mass would remain the same. So here the mass is being consumed. That is why you started with more mass and you ended up with lower mass. Here the mass is being consumed. So don't get confused between this graph and the other graph that we have done previously. Here, this was the mass of the gas which is being produced. The volume is increasing. In the second part, the mass is decreasing. So these are the two graph-based questions from rate of reaction chapter that I wanted to discuss. Let's move to the next topic. So let's move to the final question in the series. This question I found again very interesting because there are 2-3 concepts which are being discussed in this particular question. They are talking about collision theory. They are talking about activation energy. They are talking about catalysts. So the point is that in the same question, there are 2-3 very important topics which are being discussed in a single question from the rate of reaction chapter. See, before this lecture, we have already discussed in detail the effect of temperature, the effect of concentration, the effect of pressure, and we also have discussed the impact of catalyst also on the rate of reaction. We haven't discussed the activation energy till now. So in this lecture, we'll be looking at activation energy also. So let's start the question. The rate of forward reaction is determined by collision theory. So one thing that I'll suggest is that you should be very clear about this collision theory part. So when we discussed the impact of pressure, we discussed that high pressure would almost have the same impact that has the effect of the concentration. So high pressure and concentration almost behaves in the same way, and we should also go through our textbook to understand very clearly about activation energy as well as the action of catalyst on the activation energy. Because here I'm just discussing the questions, so that is why I won't be able to go into much of details. But these are the topics which are very important from a exam point of view. So rate of reaction depends upon 2 factors: frequency of collision between the particles, proportion of collision which have energy greater than equal to the activation energy. So you might have a container where there are these particles, but not all the particles would have energy more than the activation energy. Activation energy is sort of a beautiful way in which understanding activation energy is. This activation energy is a sort of this bump that each reaction has to cross before the reaction can take place. And you have gone through the textbook carefully, you would understand that what a catalyst does is basically the catalyst plays on this activation energy. It plays on the activation energy. It gives a different path so that the activation energy gets lower. So more of the particles are able to go through the bump of activation energy. I'll write it here: the bump of activation energy. This is the bump I am talking about, and this is what the catalyst does. The catalyst gives an alternate path for the reaction to take place. That is how the catalyst helps. That is how the catalyst and the activation energy are related. So the proportion of collision which have energy greater than or equal to activation energy. So define the term activation energy. So we'll have a look at the definition. Activation energy is the minimum amount of energy required for reactant to collide effectively and start a chemical reaction, acting as an energy barrier that must be overcome to transform into products. Same thing. So your wording should be exact. Please use a definition as is given in your textbook. Is the extra energy beyond the normal state that molecules require to break existing bonds and form new ones in determining how fast a reaction takes place. Okay. So we have defined activation energy. What is the symbol of activation energy? This is how the activation energy is written. And see, these are one number each question. Now, complete the table to show the effect when the conditions are changed. So, change to the condition. This is how the condition would be changed. Effect on the frequency of collision between the particles. See, frequency of collisions would be very well explained in your textbook when you refer to the collision theory part of the reaction. That is why I'm suggesting please have a look at this carefully, because you'll have at least one question based on the activation energy, collision theory, catalyst. Very important. Effect on the frequency of collision between the particles. Effect on the proportion of collisions which have energy greater than the activation energy. So this is what I was trying to tell you, that there might be only a certain proportion of the molecules which will have an activation energy which will be greater than the activation energy. So when the concentration of chlorine is increased, so there might be some reaction which is taking place. We can, if the reaction doesn't matter, the concentration of chlorine is increased. So some reaction where chlorine is being used. So when the concentration of chlorine is increased, the effect on the frequency of collision between the particles. The collision of the particles, the frequency of collisions will increase. In a previous lecture, I had told you that imagine going to a railway station in the rush hours during the office hours in the morning or evening. When you go to the morning and evening, the number of the concentration of passengers has increased. The number of people on the platform has increased. That is why the frequency of collisions has also increased. But the interesting thing is, effect on the proportion of collision which have energy greater than the equal to the activation energy. The energy of the passengers which are there on the platform would have remained the same. So for example, one way of again coming back to that platform example, due to the increase in the concentration of passengers per platform, the number of collisions have increased. But there is no effect on the energy of the passengers. The energy of the passengers has remained the same. So there is no change. So concentration has to do with the increasing the frequency of collisions. It has no effect on the energy of the particles. The energy of particles is only decided by the temperature. And that is the second factor. When temperature is increased, frequency of collision increases, as well as the energy of the particles also increases as they collide. When a catalyst is added, as I've told you before, see the bump. This bump gets lowered. Now, because the bump gets lowered, more number of particles are able to participate in the reaction. They are able to complete the reaction. It is like saying, say you have a 100 marks paper. So your teacher first said that the passing marks would be 40 marks. So 40 marks were passing. But then she saw the performance of all the students. So what she said was, no, the passing marks has been revised to, let us say, 25. So the activation energy is a sort of passing mark. Another way of looking at this is that this bump can be seen as passing marks. So as the passing marks are lowered, more number of students would be able to pass the exams. I think this would make sense. So this is what I wanted to explain. Now, if you have gone through the whole lecture, you would have seen that we have in detail covered activation energy, temperature, concentration, collision frequency. We have discussed in detail surface area. When you go through catalyst, you will understand the role. One of the things that catalyst, how they increase the rate of reaction is by providing greater surface area. Again, I will request you to have a look at your textbook. So in your textbook, they'll discuss about the action of catalyst. How does the catalyst work? There is another interesting topic, which when you look at your textbook. So here, what I was telling about catalyst. So catalysts remain chemically unchanged. They are unchanged at the end of the reaction. So catalyst, because they increase the rate of reaction, they are also unchanged at the end of the reaction, so they become very cost effective. Otherwise, the reaction would have taken at a higher temperature. And when you study the transition elements, you'll understand that transition elements make very good catalysts. That is another important question which is there in the transition elements. And in our body also, there are catalysts. Those catalysts are called enzymes, and these enzymes they work only for a particular reaction and at a certain temperature, as they have written here. Because enzymes are temperature sensitive, these powders use at wash temperature at 30 to 40 degrees Celsius. You might have heard that we shouldn't be drinking cold water when we are having our meals, because the enzymes work at a certain temperature, and cold drink or cold water affects the process of assimilation of food into our body. So, hope this lecture was useful. We covered a lot of questions from this PDF. I'll be attaching the PDF notes as well as this question paper in the comment section or the description. So, thanks for watching. Best of luck.